let's first look at Saturn's moon, Titan. It's a moon with a very thick atmosphere, specifically nitrogen. Just like Earth. Earth has 75% nitrogen. Titan is actually a lot higher, but it's still mostly nitrogen. Titan's atmosphere is 60% thicker than Earth's. So again, you'll be feeling a lot of atmospheric pressure if you were to stand on Titan. Titan is not the only moon of Saturn, but it is the largest, and it is the only one in the large category. And this always cracks me up. So, early observations suggested that there was an atmosphere. So we had Voyager fly by it to look at it, and it couldn't confirm there was an atmosphere because of haze. Well, don't you need some haze in order to form an atmosphere? Or don't you need an atmosphere in order to form haze? It's like, well, shouldn't you have confirmed that? But then Cassini is supposed to visit it. Actually, this is going to be updated, but 120 times by the end of 2017, which is pretty much past. So Cassini should have given us a lot more information on it already. Turns out it does have an atmosphere that is thicker and denser, like I had said, and it is mostly nitrogen, 98% nitrogen. Okay, Earth is 75%, so yeah, a lot more, but still. It also has things in it like methane and other gases. Now, it's a cold place, 94 degrees Kelvin. Right, Earth is 280-ish on average. They also think that there is rocks made out of ice and some sort of water, liquid water for the lava. What's interesting about Titan, though, is that it's cold enough to have methane as a liquid. They could have methane, rain, snow, and fog, and methane or ethane rivers or oceans. Okay, translation. Gas for your car. Gas for your barbecue. We have the water cycle, right? So the water evaporates, forms a cloud, rains down on us. Not that big of a deal. The methane cycle is what they have on Titan. Methane cycle. So basically imagine gasoline. Right, kind of a pure form of gasoline, but gasoline in oceans, in lakes, in ponds, in rivers, and then it evaporates, forms a gasoline cloud, and then depending on the temperature can just rain or snow gas. I'm telling you, if you take this stuff to Hollywood, they will laugh at you. So the Huygens probe, 2005, so again this is old, but it landed on Titan. And it kind of gave us an atmospheric breakdown, which is kind of what we thought. There was this haze that we couldn't see through. There's a condensation haze on top of that. Then there's these clouds made of gas. Like gasoline, not gas vapor, but gasoline. So, again, here it is. Your haze, more haze, more haze, more haze, and then methane clouds and methane rain. Right. There's actually fewer clouds than we thought there would be. And it's not quite widespread. It's pretty much only at the poles. Okay, and it's only winter or summer. So, no spring or fall rains, but still, it's raining methane. Right, so if you look at it through different light, because you have to be able to see through the haze, this is kind of what it looks like. Also, what's kind of funny is they've got icy plateaus. Well, not ice like you would think. Ice like tar. Plateaus made of tar that are frozen. And it does have some ridges and cracks that actually suggest geologic activity. And it has erosion. Well, it has a thick atmosphere, so wind erosion is not that out of order. They think there's actually some volcanic activities that would smooth in the craters. They have found a few craters, but not many. And they've found volcanoes that spew ice. So again, we talked about right at the beginning, the rocks might be made of ice and they might have this icy lava. They've found volcanoes that are spewing out ice. So you have this moon, or this world, that has lakes and rain of gasoline and volcanoes of ice. Crazy stuff. So this is a picture of near the poles, actually. I forget if it's North or South Pole. North Pole. And you can see these little pockets. So they look like lakes. I mean, they look like, if you took a picture of Florida, this is what it would look like with all the lakes and the land. Except this is not water. This is ethane or methane or propane or some form of gas stuff. And Cassini took this picture. There's no waves in these lakes or ponds or oceans or whatnot because they're made out of hydrocarbons, gasoline, which means that it's going to act like a tar almost. So it's going to be way too thick. If you dropped a rock in there, it's just going to go bloop. And that's it. It's not going to cause all those ripples and stuff. Okay, again, think about that. You have a moon full of gasoline. Our energy problems would be solved. There is just one slight problem with that. If you got there and you were able to collect some of this, how are you going to get off of the moon? You can't start a fire to start your rocket, because if you do, the entire moon would go up in flames. Right? You don't put a flame near gasoline. So it's kind of mean that it's out there. It's like, here I am, all of your energy problems are solved, but you can't get stuff off of me. So what does the inside look like? Well, we think it has a rocky core. We think it has a water or ice mantle, or both, not entirely sure. And then we have a liquid water layer. The ice and the water from the volcanoes have to come from somewhere. And then we have this surface. Here's some of the things you can see if you land on Titan. Look at those sand dunes. I mean, those look like pictures from Earth. They're not. They're from another moon, Titan. It's incredible.
January 14th, 2005 begins with the Earth passing directly in between the Sun and Saturn. Position so perfect that it occurs maybe twice per millennium. Meanwhile, the Huygens probe, quietly entering the Saturnian system, is about to end its 7-year journey. As Huygens approaches, the inner planets cluster around the distant Sun. Saturn appears almost as large as Orion. A few moons are visible as white dots aligned with Saturn's rings, while Titan, its largest moon, is already... Huygens is destined for Titan, a mysterious world larger than the planet Mercury and shrouded by a thick brownish-orange atmosphere. The details of its surface have never been seen. Huygens' speed increases to near 6 kilometers per second, and Titan's disk quickly obscures our view of Saturn and its more intimate moons. As the probe enters Titan's atmosphere, the heat shield reduces the speed some 15-fold within a few minutes. The main parachute reduces the speed further. 15 minutes later, the smaller stabilizer chute allows a faster descent at first, but slows as Huygens enters the lower, denser parts of Titan's atmosphere. Huygens is approaching a dark valley between brighter, hilly regions. Beyond the hills to the left, two dark parallel lines appear, which are later discovered to be part of a vast system of dunes which surrounds the moon. At 21 kilometers altitude, the probe moves through a thin haze layer as seen on the horizon. The bright area near the center top is the glow of Titan's haze illuminated by the sun. A complicated system of drainage channels, some hundreds of meters wide and kilometers long, are seen cut into the hillside. These are probably the result of runoff from methane rain. Stereographic imagery reveals hills to the left to be perhaps a few hundred meters tall, while features in the valley are tens of meters in height. For most of the descent, the probe travels eastward above Titan's surface. However, below 7 kilometers altitude, the motion reverses into a backward westward motion. It reverses again at 1 kilometer altitude, and we move slowly southeastward. Hang on, as Huygens lands on Titan's surface near a water ice outcropping ridge. Another westward-looking view of the descent from 31 kilometers shows the area of Titan over which the probe has just flown. This affords us a good view of the drainage channels and apparent shoreline. More dark lowlands appear and a rough pitted hillside to the left. Spectra of the surface suggest that the bright areas are water ice, and the darker areas are a type of hydrocarbon mixture that has never been produced in the laboratory. The small white dot in the lower center part of scene tracks our progress over Titan's surface. We see the reversal in direction at 7 kilometers altitude, and we fly over the ridge near where we will land. As we approach the surface, our perspective brings the topography to life. We see that although there are rivers and a shoreline, the basin is dry. Below, there are distinct signs of erosion which crafted the rugged ridgeline. Huygens sinks into one of these gullies. We experience a relatively soft landing on Titan's surface. The view from the surface reveals an amazingly Earth-like picture of a dry riverbed, with distant hills which are a few meters in height. Some seconds after impact, the shadow of Huygens' parachute drifts across the scene. The heat from the surface science lamp in the probe's skin vaporizes methane from Titan's surface, which is about 180 centigrade degrees below freezing. Near the probe, the ground is littered with water ice rocks and smaller pebbles which could be made of water ice, or hydrocarbons, or some combination thereof. Although we now know more than ever about this mysterious world, many questions remain unanswered. Where is the vast reservoir of liquid methane necessary to replenish the atmosphere? Where and how often does it rain on Titan? How does the methane get recirculated into the atmosphere? What materials make up the surface? What processes create and shape the hills, dunes, and valleys?